All right. Thank you, Dennis. So I'm going to start talking about Veliger toes and maybe have some time to go into a few other things at the end. But one of the things that I've asked for the last 3 or 4 years coming to these meetings is what are we looking for and what are we capable of finding? So how many people in here, by a raise of hands, think that we can find in a reservoir that's at least 100, a lake that's at least 100,000 acre feet, find veligers off of one individual boat that came in from a live well with the current sampling effort? Okay. How about if we have a boat that comes in with 100 adults, so 50 females, 40,000 eggs per female? Anybody think we're at a level where we can pick that up? Okay. So I'm going to talk about these things, and then we can discuss a few ways we may be able to get to certain levels of detection. But the first thing that I want to talk about is it's really hard. And Tim Cunahan and Steve Bollins put together a research effort on some Columbia Basin reservoirs, and they concluded that it's really hard. We're not putting in enough effort to have a high confidence in being able to detect these individuals. I'm a numbers guy, so not doing enough work, what does that actually mean? I couldn't find anything with actual veligers, so the closest thing is another invasive plankton, spiny water flea. In this example, they were out there with normal sampling for 15 trips a year, and they think that they missed the first 14 years of that population increase over time. They were able to detect that with sediment samples, and they're picking up the tail segments of the spiny water flea back down in the sediment at depth, so they were able to figure out how many years it was there without being detected. So if you take their empirical model and push that out to veligers, we would need to have a boat that maybe takes a whole lot of water. So the worst case scenario boat from Dalton and Cottrell, 2013, it's about 300 gallons, is probably the worst case recreational boat, not giant sailboat getting moved around. So in a reservoir the size of Jackson Lake, you're needing thousands, if not tens of thousands of samples to be able to pick up the veligers from that worst case boat coming in with just veligers. So I'm glad that nobody raised their hands. Hopefully you weren't just shy, but I don't think that we're at the level with veliger toes to be able to pick up these individuals coming in. Even if they were secluded in a small marina. So this is Coulter Bay Marina within Jackson Lake, somewhere around 500 acre feet. If a boat with 300 gallons and 250 veligers per liter comes in, you're still going to need 3 10-meter toes in that little tiny marina area to expect to be able to detect if you're making the assumption that veliger detection is similar to spiny water flea detection. You could also look at if you just put a ring out there that was the size of a zooplankton net with no drag, no clogging, the amount of water that would pass through that ring in a 10-meter tow, you're still going to need at least 2 with perfect instances in 500 acre feet of water to be able to pick up that population that could come in off of a theoretical worst case boat. So in reality, we're talking thousands, if not tens of thousands of adults needed, depending on the size of the water body that you're looking at, to be able to detect with the current effort that we are looking at as far as Veliger tows go. So if you take a local example, Flathead Lake, with 1,000 adults using the empirical model on spiny water fleas, you would need 75 tows every 4-week period when they could be reproducing. On the empirical model, and 38 tows of 10 meters each, so basically a quarter mile of towing to be able to pick up one individual Veliger if they're completely mixed throughout the water column. So maybe they're not completely mixed throughout the water column. We can talk about that as we move on. So we're looking for a needle in a haystack, and how can we take the information that we have and be able to make those haystacks a little bit smaller? So spawning is thought to be temperature induced. There's also some literature out there showing that spawning can be induced by high volumes of plankton in the water column. Does wind have the ability to concentrate Veligers or not dilute Veligers? Can we improve the risk information? So if we only have a certain amount of time that we can send crews out, then making sure that we're going to the right reservoirs and the right places within those reservoirs where not only are they likely to be introduced, but they're likely to establish once they come in. And then talking about some alternative sampling methods. So if you look at the distribution throughout the United States, a lot of the concentration is near the Great Lakes where they were initially introduced. But what is different about the West? So if you look at EPA's standard water body measurement, this was the easiest map that I could find with the generic where are the lakes, where are the reservoirs. So if you look at the West, there's a lot of reservoirs out there compared to that concentrated area where introduction first happened and you have a lot of establishment near the Great Lakes. So in the West, I looked at the 100 largest water bodies by surface area. We have 11 undammed natural lakes, 63 reservoirs, and 26 dammed natural lakes. So even places that a lot of people think are a true natural lake, Pend Oreille, there's 11 feet of water level fluctuation. They drop it down during the winter and raise it back up during the summer. Flathead Lake is similar. Tahoe has some fluctuation, but it's not a winter-summer thing. It's over a number of years. Back to 2015, I looked, and there's an 8-foot difference in water level. So how the water level changes, when the water level changes, could influence those temperature regimes. And I'll get into that in a little bit. So just the idea that in the West, 89 of the 100 largest water bodies, or 92% of that surface area, is in some way controlled by a dam, whether it's a reservoir or a raised natural lake. So what's different about reservoirs that we may be able to learn from in order to optimize our sampling efforts? There's the obvious drawdown, the associated temperature regimes with that drawdown. There's anoxic zones that change year to year. And there's also residence time for some of these run-of-the-river reservoirs. They may be large, but they may also have a lot of water going through them if there's other reservoirs upstream. So if we look at what I'm calling little wine glass diagrams, in the spring, a lot of us are starting sampling. The reservoir is full. You draw down throughout the year. And if you are assuming or want to believe that, or don't want to believe, that most likely we are looking at a population that is reproducing in the water body that you're in. getting tens of thousands of adults that come in alive, able to produce 40,000 eggs per adult, is, in a whole reservoir-wide situation, probably not going to happen. So if you have the only way they're going to survive over the winter, they need to be in this zone that is above the anoxic zone for before your fall or before your spring turnover, and below the low water line for the winter. So if you add temperature into this, in the spring, your surface temperatures are optimal for spawning, but then anything that survived the previous winter is down here. So if you're basing your sampling regime on surface temperatures at a water body that has these high levels of fluctuation, you're looking for that boat that came in with veligers, or you're looking for that boat that came in with some adults. And some of us thought that that was possible, but it takes a lot of adults coming in an individual boat. So we're most likely looking at something that can survive over the winter that then is going to be in that optimal temperature zone for reproduction midsummer into fall. So if we have 92% of the surface area in the West managed somehow by a dam, and we're not thinking about how that impacts our sampling regime, if you have a lake that is right next to a reservoir and you use the same sampling regime on both of them, we may need to think about how that works. Is that really the best way to spend the limited amount of time and the limited amount of dollars that we have? A lot of our reservoirs, especially the ones with low residence time, the fall has the biggest plankton blooms. We have spring pushing a lot of water between reservoirs, so even if there is some development, it gets washed downstream. So especially around fall turnover, when the temperature at the depth that they could survive is there at the right elevation, we also are getting those plankton blooms that may be another cue for them besides temperature to spawn. Veligers that are spawned in the fall are also more likely to survive, because if they're spawned in the spring, they're going to most likely stay above the thermocline. If they're above the thermocline at a highly fluctuating reservoir, then they may not survive the winter as they get desiccated as that water level drops. And if you're out there and you have the ability to do DO sampling, that would also enlighten that understanding of where the habitable zone is within an individual water body. So then, which haystacks can we prioritize? One of the ways that we are going about this is I've gotten some money through an S&T grant from Reclamation to fund USGS to improve upon the risk modeling that's already been done in the Columbia Basin, and put together a heat map type web application for establishment risk, and they have some other funding that they're going to be looking at introduction risk and improve things in that way. So on top of that, what can we do to look at these things? So our residence time between reservoirs and between a reservoir and a lake, how much drawdown is there? What time of year does that happen? Are there anoxic zones within a reservoir that may limit where you would be sampling? And anything else that may come up. So looking at residence times, taking some of the places that I work, Minidoka Reservoir, it's a run-of-river reservoir. It's still pretty big. It's almost 100,000 acre feet. But with 9,000 CFS going through that every day all summer long during the time frame where temperatures are okay or optimal for spawning, you get a 20-day residence time. So anything that spawns in that reservoir, are those veligers going to be there when they're ready to settle? Or if you find a veliger that's settled in that reservoir, is it actually something from upstream? Jackson Lake is a headwater dam lake. There's a lot larger volume of water in there, smaller inflow, so you got a 634-day residence time. That may be someplace to prioritize higher than someplace that has a 20-day residence time. And then a natural lake, Yellowstone Lake is huge, but there's only 11 that I could choose from on the list in the West, and that is one that I figured you guys would know about. So 17-year residence time. So there's no worry about the veligers that are there getting washed downstream, and there is a worry about veligers that are getting washed downstream, but the time it takes for them to actually settle out and be a problem for that water body would not be taken into account like there would be at Minidoka. So some more wine glass diagrams. Anderson Ranch Reservoir is one that we have a lot of data on out in the Boise system, and we don't fully understand why, but it has a large anoxic zone. So we go quite a ways off the bottom in really high water years with low dissolved oxygen. In low water years, we draw down quite a bit, so that elevation that was below 2 milligrams per liter in some years is also dewatered. So over time, there might not be a long-term habitat suitable for mussels to survive in that reservoir. Just another way to think about things and be able to prioritize between the areas that you're looking at. If we can't do enough sampling, this might be something that you can look into to see where you would want to be doing your sampling. Another thing that I looked at was where these initial detections are occurring. I kept on hearing in a lot of these meetings, our first detection was at the boat ramp. It was in the marina. If you look at some of the reservoirs that I work on, our boat ramps are wind scoured, and if you look at the wind mixing, there's studies that show that the veligers are relatively evenly distributed within reservoirs on a horizontal scale. They may be at increased densities just above the thermocline, but if you have an area that is not protected, then a lot of your veligers are going to dissipate during that 4-week time frame out throughout the entire reservoir. So I didn't understand why all of these initial detections with my limited scope of reservoirs to work on were going to be at boat ramps. So I started to take a look at some other areas, and I forgot that this was in here. So this is what I was just talking about. Does a marina itself, the shape of it, determine whether or not they could establish there? Do you need a high enough density? Are those veligers that get spread throughout the entire reservoir, once they settle out, can they successfully reproduce at such a low density that came in off of an individual boat? So the first place that a lot of people go is the first place that was introduced to mussels out here in the West, Lake Mead. If you look at the boat ramps that they have at Lake Mead, they're relatively secluded areas where the wind might not be able to mix with the rest of the reservoir. There's wave barriers that are out in front, limiting the mixing even more besides the natural bay that some of those marinas are in. So permanent floating structures secluded areas that are limited in mixing. That's one reservoir. I wanted to take a look at a few more things. I started looking in Texas and moved out a little bit. All of the places that I looked had boat ramps and marinas with permanent floating or built structures that were always going to be in the water, or they had a wave barrier around the outside of them. I looked in the Midwest, same thing. All of these areas that were infested in the Midwest have some sort of permanent floating structure that in some cases is extremely secluded from the rest of the reservoir. I looked in the Northeast too. It's not the same. There's some places where there's very little infrastructure and there's still mussels in there. That may have something to do with when introductions were happening and the amount of time that people have been able to move things around in that area and the number of infested lakes that are out there. So we go back to some of the more Western examples, Palisades. Like I said, the two main boat ramps are pretty open and able to be scoured by the wind. You would expect a lot of mixing. There's no secluded area for concentration of veligers to be able to survive, but it's got high calcium levels, and since I came on, I've been calling it high risk. You look at Jackson Lake, it's got medium risk calcium levels, but it has this very secluded marina that has permanent floating structures, and I don't know if I want to call that medium risk anymore. So looking at the risk of things coming in, hopefully we can prioritize down the road and be able to determine where sampling should be occurring, where things are likely to actually be able to survive and reproduce over time. In some of those instances where we don't want to stop sampling entirely at some of these places, but if we aren't going there as frequently, then we may need some alternative sampling methods to be able to pick up detections if we're going to a water body less frequently than once every 4 weeks. So one of the things that I was looking at based on that Spidey water flea paper that I talked about earlier is making our haystack smaller by going from a 3D water volume to a one-dimensional plane of the sediment. The marine stow stage, so if you have veligers that are settling out or 90% of them die off and fall down to the bottom, can you pick those up in some manner or another? So I worked with Yale. We got a science and technology grant put together. Hopefully we find out if we get funding sometime in the next week or so, but it looks promising to be able to look at the sediments in areas where we do and don't have mussels, in areas that they've been established for a long period of time, and areas that they have not been established for a long period of time, and starting with just eDNA of those sediments themselves. We heard Chris talk earlier about sediments can hold DNA over a long time, and that is potentially a negative, but it might also be a positive for us to be able to detect something if we're not there when the veligers are actually in the water column for a short period of time. So a couple of things that I've seen during this meeting, I like the idea of the robot going along at the thermocline. I'm not sure if we can all have robots going along in the thermocline, but maybe something less technologically advanced, like a weight and a thermistor, so that you know where the thermocline is and be able to do that. Because if you do have a concentration of veligers that's anywhere out there in the reservoir, looking at alternative methods to be able to detect those veligers that are there whether that is sample locations, whether that is elevations within the reservoir, whether that is pairing things with eDNA. It was a wake-up call to me to see that you pretty much need a substantial reproducing population in the reservoir or water body before you're actually able to pick them up. So if we want to get to a place where we can find things a little bit easier, there's some other ideas to go out there and instead of just sampling the same way at all the water bodies that you go to. If there's, you have lakes, you have reservoirs that you're sampling, you start your lake sampling earlier in the year, you continue, add on your reservoir sampling, and then as you get towards the end of the year, you can drop off some of the lakes and continue the reservoir sampling. It may be as simple as that, or you could have all of the information that you want to be able to determine where and when within a certain reservoir sampling may be more beneficial. And with that, I will take any questions if we have time.
Any questions for Anthony? Yes.
So, given your statement that it takes a large population of reproducing adults to detect a Veliger, how do you explain Montana's situation, Colorado's situation, where we see Veligers in the samples and then can't find it in the mix years later?
There's probably a lot of places that may have happened that we haven't detected it too. So that may be one answer, and there's certain concentrations, and I think the Tiber stuff, if you have wind blowing in one direction, that would have blown the Veligers to the side of the reservoir where they were detected. I don't know enough. I don't have the answers, but if we look at things in a way to say, okay, we aren't sampling enough, can we sample any smarter? So if you look at wind direction, if you look at any of the variables that could enlighten your choice in timing, your choice in location, to be able to improve your chances of being able to detect things, then that's,
I agree with definitely with that part, but
hopefully they're not getting distributed throughout the entire reservoir. So if they're concentrated in a certain area and you're lucky enough to do your sampling at a high enough repeat interval so that you get there close to the time frame when they were released instead of when they're mixed throughout the entire reservoir, it might just be that there's some places that we might be missing these things too. Because establishment based on some of the information may not be as likely if you have boats coming in from the southwest in the spring and your Veligers get released into the water column and then you draw down your reservoir. So a lot of our places that they may have seen introductions. We had a boat in Jackson Lake with mussels on it back in 2008, and the engine wouldn't start, so they looked into it, and the engine wouldn't start because it was clogged with mussels. So we know it's happening.
lower limit for anoxic conditions that also most provider. But you and I need to talk later.
Comment about anoxic condition levels that we're going to have a side conversation about.
Anthony, how do you think the run-of-river reservoirs that are, somewhat common in the west, northwest, how does that, do you think, change the picture of water temperature, anoxia, DO, or maybe not at all?
Minidoka doesn't really develop a thermocline. It has so much water going through it that if you're trying to look for where the concentration would be, that there's the thermocline. Once in a while, it's pretty weak. If you have a run-of reservoir, one of the things I don't know is how far downstream, if it's a meandering river, if it's class 5 whitewater river, how far downstream can those things survive? That I don't know. So I'm just bringing up some ideas that I've had questions on things over the past few years and tried to throw something in to make people think and not necessarily give anybody all of the answers, because nobody can do that.
Thanks, Anthony.